So we are going to look at a second type where direct substitution does not work. And then when that happens, we have to do a little bit more work for these. So sometimes when you do direct substitution, you plug in your x value into your functions, you are going to get 0 over 0. And this is called an indeterminate form. And what that means is I don't know what the limit is. I can't determine it from direct substitution because I get 0 over 0. So it doesn't mean that it's equal to 0. It doesn't mean it doesn't exist. It just means I don't know, and I have to do more work to figure it out. On a graph, what it looks like is at that value that I'm looking at, like the limit as x approaches a, when I get 0 over 0, what is happening on the graph is that there's a hole. And so if there's a hole, remember the limit does exist. It's whatever this function is approaching from both sides. Like this function is approaching the same value from the left and to the right when we did it graphically. But the value at a does not exist. And that's what 0 over 0 represents, that the value at that exact point, that y value doesn't exist, but the limit does exist because from the left and the right, they're both approaching that same y value. So this is still b. Okay. So how we figure it out is what we can do is we can factor our numerator and denominator, or sometimes it's only one. And what will happen is there will be a common term. And that common term we can cancel. And when we do that, we will get a simplified function that is the same as this function that we drew, that is the original function, everywhere except at x equals a. The simplified function at x equals a does exist, and then we will be able to directly substitute our x value in and get a value that's not 0 over 0. Okay. So you will have to remember all of your factoring techniques. If you're a little rusty, you may want to look up some of them. The main ones we will be factoring a lot is the difference of perfect squares, like this x squared minus 9. We'll be factoring a lot of trinomials, mostly with the leading coefficient of 1, occasionally not, but most of the time leading coefficient of 1. And then we'll do, this is rare that it will show up, but I'll do the difference of perfect cubes. So I want to find the limit as x approaches 3 of x squared minus 9 divided by the quantity x squared minus 10x plus 21. So the first way you should always start is plugging in that x value and seeing what we get. Because if you don't get 0 over 0, then you can just be done and get your value. But in this case, we are going to get 3 squared, 9 minus 9, which is 0. And if you calculate the bottom, you get 9 minus 30, which is negative 21, plus 21, which is 0. So when you get this, don't put 0, don't put indeterminate form. It just means you have to do more work. And so what that means is you are going to have to factor. Okay, so as a reminder, when you have x squared minus 9, that's the form a squared minus b squared. It's called the difference of perfect squares. So it means that the number that you're subtracting has to be a perfect squared, which means you can take the square root of it and you get a whole number. So the square root of 9 is 3, so 9 is a perfect square. And when we factor this, it factors to whatever the square root of a squared is a, and that comes in the first spot of both. And the square root of b squared is b, and that comes in the second spot. And then one is plus, the other one is minus. And which one you put first doesn't matter. But if you multiply this out using FOIL or the distributive property, you would end up getting this, and that's why that works. So when I factor x squared minus 9, again, it factors to two binomials. What multiplies to x squared is x times x. So the square root of x squared is x. What multiplies by itself times 9 is 3 and 3. And then again, one is plus and the other one is minus. So that's what that factors to. The denominator is a trinomial. When I factor a trinomial, when it's just x squared, so the number in front is 1, what we do is we think about what multiplies to the last value, which is 21, and what adds up to the middle value, which is -10. And it has to add to that. Okay? And make sure this is in order. It should go from the highest degree to no degree. So we think about, okay, what multiplies to 21? 21 and 1, which obviously is not going to give me -10. 7 and 3. But in order to get a -10, I need both of them to be negative. Because if I multiply them both and they're negative, I get a +21. If I add them, I get a -10. So this will factor to, when I factor this, the first term in each binomial is x and x again, because that multiplies to x squared. And then we put the -7 and plus, oh, sorry, -3. Again, the order doesn't matter. Okay. So that's what I factor. If you're not like 100% sure, you can always multiply it out and make sure that you're getting the original expression. But what should happen is when I get 0, 0, there should always be a common term. So x -3 is on both the numerator and denominator, so those cancel. And then now I'm going to write again the limit with the simplified expression. And now I can substitute in my x value. And I will no longer get 0 over 0. I will get a value. So 3 plus 3 is 6. 3 minus 7 is -4. 6 over -4 simplifies to 3 over -2. And so that's what this value of the limit is, -1.5 or -3 over 2. Okay. One thing with notation, and this will matter for the exam that you're writing this correctly, is that you write limit every time unless you're plugging in that x value. And when you plug in that x value, you do not write the limit because the limit is an operation and you're taking the limit, kind of like you're adding or subtracting. And so once I do that, I don't put that symbol anymore because I actually did it. When I'm just factoring and simplifying, I haven't done this limit part yet, so I still need to write it each time until I actually plug the 3 in, because that represents me taking the limit. Okay. So that's one example. We'll do one more in this video, and then I have another video with a few more examples. So I'm going to rewrite it down here because I'm not going to have enough room. So x cubed minus 1 over x minus 1. Okay. So again, we start the same first way. Whenever we do a limit, the first thing we should try is direct substitution. So I plug in my x value. But if I do that, 1 cubed is 1, minus 1 is 0, 1 minus 1 is 0. This again is indeterminate form. So I don't know the value. I have to keep doing more work to figure it out. Okay. So this is a tricky one. It won't show up very often, but just in case, I'll go over it. This is called the difference of perfects cubed, a cubed minus b cubed when you're factoring it. So it factors to a minus b. You get a and b by figuring out what times itself 3 times, or the cube root of it. What is the cube root of each of these? And then the second one you find by doing whatever a is squared, and then it's plus, it's always the opposite sign of this one, a times b, and then plus b squared. Okay. And just in case, if you ever have an a cubed plus b cubed, it's very similar, just opposite signs. So it's a plus b, a squared minus ab plus b squared. So we need that to be able to factor this top. So when I factor x cubed minus 1, this is my a cubed minus b cubed. So a is just x, because x times x times x gives me x cubed. And b, the cube root of 1, or what times itself 3 times is 1, is just 1. So that's my a and my b. So this will factor to, using this first one because it's the difference, would be x minus 1 times, and then I have whatever a squared is. So that's x squared plus, multiply these together. So 1 times x is x plus b squared, which is 1 squared, which is 1. So that's what that factors to. The denominator then I'm going to factor. Well, in this case, I don't have to. It's just x minus 1, so that's nice. I don't have to factor anything. Again, anytime we get 0 over 0, there should be a common term. If there's not, you most likely factored incorrectly. So this x minus 1 will cancel. I did not plug in my value yet, so I'm continuing to write the limit notation. And now I'm going to plug in my 1. Okay, and so I get 1 squared, which is 1, plus 1 plus 1, which is 3. And so this limit is 3. Okay, and so those are 2 examples of how to do the indeterminate form. So let me know if you have any questions.